So let's pick up with number 3, which asks you to get box plots for fem and manti. So the way you would get a box plot is to go to graphs, then legacy dialogues, and then come down here to box plot. And we just want a simple one for now, and we're going to collect summaries of separate variables because groups of cases would be if we were looking at, again, like femininity, and we wanted a separate box plot for males and females or different groups of cases. Here, all we care about is for separate variables, so we just want one box plot for each of the variables that we listed in the project. So you just say define. So I'll just keep fem for now. You're also going to need manti. And let me just see what options. You can just go ahead and click continue. Don't change anything in options. Click OK. And let's look at our box plot for fem. So generally speaking, when you see values that fall outside of these two bars, it suggests that they're outliers. And then also this black line right here represents the median, always, no matter what box plot you're looking at. And the large majority of values fall wherever this box is. There's different cutoffs. I'm not exactly sure what the percentage is in SPSS, but it's a large majority of values fall here. You can look it up on Wiki, and I'll tell you what it is in class. I forgot to look it up. So that's a box plot. And then for number 4, if you didn't do it last time, you have to get a stem and leaf plot. So really quickly, analyze, descriptives, explore, and you're looking for fem, so you just put fem in here, obviously, for dependent. And then for plots, you would click off stem and leaf instead of histogram. Click OK. And I know Bill went over this in class, so I don't think I have to go through it again. So that would be your stem and leaf plot. You can copy and paste that right into your homework. And now on to the fun stuff. Now we're going to switch data sets, and we're going to move on to number 5, which is the beginning of the missing values analysis. So let's go ahead and do that. I'm going to open up. So for this, you need data M. So I'm going to go ahead and do that. Data M. All right, and I'm going to close my other set. We're done with data 1 for now, so I'll click out of that. And you'll see on data M that there are a lot of missing values in here, which isn't good. So what we're going to do is use EM or estimation maximization and multiple imputation, 2 different methods to estimate values for these missing values. So let's start with number 5A, which asks you to create a missing values index that's coded 0 if the participant isn't missing any data, or 1 if they are missing anything. So the first step for this is going to be to compute a variable that will count the number of missing values. So we'll go to transform, compute variable. I'm going to call this nmiss to stand for number missing. And then if we come across and we go to function group, you'll actually see when you scroll down a missing values function. And you'll see nmiss, whoops, here, nmiss. This just came up because, let me just double click again so you can see what it looks like. I clicked on too many things. So if you just click on nmiss like that, and then we care about ID and gender have no missing values. So you don't have to worry about counting missing values for ID and gender. We're only going to put in hostile sexism through this manti, or you know, for you guys that'll be all the variables except for ID and gender. I think I have it set up the same right now. So you just put these all in, and you have to have commas in between them. Like right here, it shows you what the syntax needs to be. So you just double click, comma, double click, comma. Whoops. Just do this until you're done and you have all of them in there. Okay, so like I said, this will count all of the missing values in any of these variables for each person. We'll say okay. Let's take a look at the value. All right, good. So we know this worked because this person's missing 3 values and it counted 3. Likewise, missing no values and it coded 0. So now what we need to do is take it one step further and create a dichotomous variable that is 0 if they're not missing any variables, and 1 if they are missing 1 or more. So again, we will go to transform, compute variable, and let's call this nmiss01. And so like we said, we want this to equal 0 in certain cases. So the way that you stipulate which cases those are, you would just click if, include if case satisfies condition, and you can probably guess what this has to say. Nmiss equals 0. So it's going to equal 0 if there are no missing values. That's what we just told it. Click OK. Let's take a look. And it looks like it did it successfully. So now we just need to code for 1. So transform, compute variable. We'll leave this the exact same, but we'll say if it equals 1, we want it to equal 1 in cases where nmiss is greater than 0. Click continue, and then okay. Change existing variable. Yes, we want to change it. So now it'll keep your 0 coding and it'll add 1 wherever there's a value greater than 0 for nmiss. So we can see just by scanning that that worked as we wanted it to. And the next step is going to be to correlate this index variable with the rest of your quantitative variables using the pairwise option. So the way that you're going to do that is to go to Analyze, Correlate, Bivariate, and then, like I said, ID and gender aren't missing at all, so don't worry about putting those in, but we'll want to put in all the other variables, and we want to put in our missing index variable right here, because that's what we want to correlate everything with. So everything goes in one box, and then we're going to get a big correlation matrix. And in order to specify that we want pairwise, you'll see if you click on options, this missing values options, click on exclude cases pairwise. It should be the default. It almost always is, so make sure that that's selected on yours. And click continue. And okay. All right, so if we look here, you can see what we're really interested in is if our missing values index is correlated with any of the other variables. We'll talk a little bit more about the meaning of that when we're in lab, but think about it. You can probably figure out why we would want to do something like this. And then you would just report this correlation matrix in your homework. Either print out the output or copy and paste it in. Let's see. So next up, we have to do a missing data analysis that might not be in your student SPSS. Like Bill wrote, you might need to go to the lab for this, so I'm not sure whether or not your student version has this. If not, don't worry, it takes 2 seconds. You can partner up with someone to do this. Even if you are partnering, I want a copy of the output in your homework. So just make sure that you have your own copy, even if you're sharing with someone for this part. So what you're going to have to do for this, the first question, part C, asks you to use the missing data module in SPSS to estimate missing data using the EM option. So EM stands for estimation maximization. So we're going to do this first. And the way that you get to that is Analyze, Missing Value Analysis. We'll put in, you'll notice it says quantitative variables and categorical variables. The only ones we care about happen to be quantitative, But let's say you did have missing gender variables. Obviously, you would put that in categorical variables right here. We're not going to do that. We don't need to. So just put your quantitative variables up here. And then in this section that says estimation, we want to use EM, like the project says. And then once EM is checked off, these boxes become available. So click on the EM box, and we want to save our completed data. And it's going to save it in a separate data set. So you'll have this original data set, data M, with all of these missing values, and then you're going to have one with all estimated values that fill in these missing values. And we're going to call that EM data M. So it's going to be a completely separate data set with missing values estimated by this model. We'll click continue. And you can leave everything else the same. Yeah, you can leave everything else the same for now. And we'll click OK. All right, so if we look at our output, this is missing values analysis. What we care the most about is, scroll down a little bit. I know the project doesn't really specify anything, but what I want you to add, show me that you did, I want you to take this box here where it says, here we go. I want you to take this box, the EM means box. And what I want you to take note of, probably one of the more important things about this, Little's MCAR test is a test with the null hypothesis that the data are missing in a random way. So if you can't reject the null, meaning if you got non-significant values, which we did, it suggests that the data probably are missing in a random way, which is a good thing. We want our data to be missing in a random way. We don't want them to be correlated with a particular variable, because that has a lot of implications for our data, and it makes it harder for us to impute data later on, which we'll talk about in lab. But why don't you just copy and paste this in so that I can see that you actually did the EM analysis, and you should be all set for this part. And again, you'll see, look at the significance value. If it were significant, like I said, you would reject the null and you would conclude that your data are not missing in a random way.